Hello friends, in this session we will discuss about the demand forecasting. This is part of the production planning and control, and before deciding that what should be the volume of production, we have to estimate the demand in the market. And forecasting becomes the important part because before doing the any plan for the manufacturing on the shop floor, we have to decide the volume of production. It is said that the forecasting is always wrong, but we have to use the forecasting to estimate the demand. Without estimation, we cannot start the production. So, demand is estimation is an important part. And in this this session is divided into two parts. First one is concerned with the qualitative forecasting and quantitative forecasting. Under the quantitative forecasting, time series model is considered in this part, and we will discuss about the causal method in the another part, that is part 2, and the seasonal variation in the demand in part 2. And in first part, basically we will be dealing about the qualitative forecasting and the time series model of the forecasting. Now the forecasting is predicting the events in future based on the past data, based on the past event, etc. And it is defined as the predicting, projecting, and estimating some future events and condition which is outside the organization's control. That means on market or the event in the market is not under our control. So we have to do the forecasting or for the estimation of the demand in the market, and accordingly we have to adjust our resources or our capacity. So this is one of the method to do the forecasting, that is the qualitative forecasting. If suppose the past data are not available, and then we want to do the forecasting and there is no existing pattern of the forecasting, then in that situation we use the qualitative type of the forecasting, otherwise we use the quantitative forecasting. Now, what are the characteristics of forecasting? As I said, that forecasts are normally wrong since it is an approximation of demand estimates in the future. This estimated demand may not be equal to the exact demand in the future. Therefore, there may be minor variation or the major variation between the estimated demand and the actual demand. This is the reason that it is said that forecasting is normally wrong. And then a good forecast does not have the single value, that is the mean value. It has some another value, that is in terms of the standard deviation or the accuracy range. So if I say that the demand of the product in the market in the next year will be 1000, so this is not meaningful. We have to see that what is the standard deviation. For example, plus minus 50 cars, this is just like a standard deviation. Or we can say that the plus minus 3% accuracy, I am forecasting that 1000 cars will be in the demand. So this is the method of the forecasting. We cannot show the forecasting value in single term. Therefore, there will be requirement of the standard deviation or the accuracy range. And aggregation of the products in the forecasting gives more accurate value because there is a opportunity to adjust the demand from one product to the another product. So this is the reason that aggregate demand forecast is more accurate in comparison to the individual demand of the product. And accuracy erodes as we go further into the future, because if you do the long term forecasting or long range forecasting, then there is more uncertainty in the future and we cannot predict that uncertainty accurately in the future. So due to this reason, the demand will be very difficult to show that what will be the exact demand. That means the estimated demand will have more error. Now, the forecast should not be used to the exclusion of non-information. That means non-information should also be used for the forecasting, and it cannot be avoided. In this case, here you can see that long range and medium range and short range forecasting, and for what purpose these forecastings are used, and what is the time horizon for these forecasting. Long range forecasting is used for more than 2 years, for 5 years, 3 years, 10 years, etc. And medium range planning is used for 3 months to 2 years, and less than 3 months we use the short range forecasting. And for long range forecasting, this may be used for the product lines, factory capacities, planning for new products, capital expenditure, facility location and expansion, research and development. Similarly, the medium range forecasting may be used for the product mix, departmental expansion, sales planning, product planning, and control. And similarly, the short range forecasting may be used for the planning, purchasing, scheduling, etc. on the shop floor. So this is related to all the different kinds of the shop floor, smaller activities like job assignment, job design, job rotation, etc. So this is part of the short range planning. Now, what are the steps of forecasting? How to do the forecasting? There are certain steps. At first, we have to decide the objective of forecasting, why we want to do the forecasting. And then second step is to find the items for which we want to do the forecast. What are the items for which we want to do the forecast? Then determination of the time horizon, that means for how many times we want to do the forecast. This is long range forecasting or medium range forecasting or the short range forecasting. Then selection of the suitable forecasting model. All the forecasting model cannot be suitable for all the different types of the forecasting, because there is a specific nature of the product or the market. So in the particular situation or the particular type of the product, we have to identify that which model will be most suitable. And then in the next step, we collect the data and feed the data for the forecasting, and we check the accuracy of the forecasting. If the accuracy is satisfactory, then it's okay. Otherwise, we have to go for the other model of the forecasting. And then finally, after seeing that if the forecasting accuracy is good, then we do the forecast of the demand and implement the result in the organization. And there are four types of the qualitative forecasting. Qualitative forecasting is completely based on the intuition, experience, expertise, etc. And we avoid to use any mathematical type of the model using in the qualitative forecasting. And qualitative forecasting is normally used for the new type of the product or the forecasting patterns not existing. Then in that situation, we use the qualitative forecasting. There are a number of methods to conduct the qualitative forecasting. The first one is executive committee consensus. In the case of the using the executive committee consensus, a number of executives sit together and they decide that what should be the value of the forecasting. And on the basis of consensus of the executives, we decide the forecast value. And then is Delphi method. In the case of the Delphi method, the number of people involved in this case, approximately 12 to 15 people are involved. And these persons do not make interaction physical with other member of this Delphi committee, but the questionnaire is circulated through all the different persons and they give their opinion, and the other person also give their opinion on the same questions, and it is again circulated. So after 2 round, 3 round or 4 round, a solid information is obtained from this opinion of the different people, and finally we do the forecast. So this is all about the Delphi method. And then survey of Salesforce are in direct contact with the market or the people, so they can give the actual picture of the market. So the survey based on the Salesforce, again we do the forecasting. Then expert evaluation technique. In the case of the expert evaluation technique, a number of experts from the different area, this may be the sales area or the marketing area, these experts gives some evaluation, and on the basis of that evaluation we decide that what should be the forecast or the demand in the near future. Now there are certain advantages and disadvantages in the qualitative forecasting. The one of the advantages of the qualitative forecasting is ability to predict the change in sales pattern. So if there is any change in the sales pattern, we can observe it visually and we can incorporate in the forecasting. Similarly, the another advantage of the qualitative forecasting is to incorporate the rich data source consisting of their intuition, experience, expert judgment. That means we can include these things in the qualitative forecasting, but in the case of the quantitative forecasting, we cannot incorporate the intuition, experience, and the expert judgment type of the information. Now, with these advantages, there are a number of disadvantages with this qualitative forecasting. These disadvantages may be related to the availability of the perceived information or not, and then unable to process the large amount of complex information because we do not use any model, any mathematical model. So processing of the large amount of the data is impossible in the case of the qualitative forecasting. Then sometimes overconfident forecasters about their ability to forecast accurately, they become overconfident and they make argument in place of accepting the realities. So this is one of the disadvantage of the qualitative forecasting, and this forecasting may influenced by the political type of the factors. These political factors may be within this organization or the between the organizations. This also affects the qualitative forecasting. Then inferring the relationship or patterns in the data when there are no patterns. If the no pattern exists, then we infer some pattern which may be related or may not be related to the forecasting of that product, and but we try to correlate with that pattern. So this is one of the disadvantage of this method. Then influencing by the initial forecast when make qualitative forecasting. That means the initial forecasting is already considered for the current forecasting, and we make the reference of that forecasting. So this is one of the disadvantage. Then reduction in future ability to forecast accurately when a forecaster tries to justify rather than understand a forecast that proves inaccurate information. So this is just like making the argument and don't not accepting the realities or the inaccurate information, avoidance of the inaccurate information, etc. Then it may lead to inconsistencies in judgment due to moods and or emotions of forecasters, as well as due to the repetitive decision making inherent in the generating multiple individual product forecasting. Then the this is an expensive method. It takes time because we have to plan in the proper way that how to collect these people for the forecasting, and there should be the proper planning and there is a time consumption for this planning. Now, the quantitative forecasting is based on the assumption that the forces which generated the past demand will repeat in the future. This is just like an assumption, and on the basis of that past, we project the future and we give the forecasting based on the some mathematical data and mathematical analysis. Analysis of the past demand patterns provides a good basis for forecasting the future demand. Majority of quantitative approaches fall in the category of time series analysis. Time series analysis means the relationship between the time and demand, how the demand varies with time, and we use the time series analysis. Another analysis is also used, that is causal method. Under this causal method, not only one variable, that is time, is influencing the demand, but we consider a number of other factors also that influence the demand, and we use the causal method like econometrics method or the regression analysis, multivariate regression analysis, etc. Now this shows the type of variation in the demand. The first one is this figure in A shows the linear relationship between the time and the demand. Time is shown on the x-axis and demand is shown on the y-axis. If this type of pattern exists, then simply we can use the regression analysis. And here we can see that this is the seasonal variation. There is a the continuous growth in the demand, but there is a seasonal variation. In a particular season, demand is very high, but in another season, demand is very less. So in this way, we can observe that there is a seasonal variation in the demand. And there may be some seasonal product like the winter cloth and summer cloth or the rainy coat, etc. So demand of these products in the particular season is more, but in another season this is very less, or you can say zero. Similarly, there may be the cyclic repetition in the demand. Cyclic repetition means after a certain period, this may be the 2 years, 3 years, or 5 years, the demand repeats. This may be observed in the fashion industry, that the fashion repeats itself after the 4 year, 5 year, or 10 years. So in this way, demand is also repeated after the certain period of the time. So this is known as cyclic variation in the demand, which is shown in figure C. Now, this is D, that is the random variation. In this scatter diagram, we can see that there is no trend exists here. So there is no relationship between the time and demand. So in this case, doing the forecast is very tough, and in this situation, we may use the qualitative type of the forecasting. If there is no trend exist in the demand on the scatter diagram. Now see the time series forecasting. Here we use the four types of the method. One is the NAV method, then simple moving average method, then weighted moving average method, and then exponential smoothing method. Name method is nothing but this is using only the previous data for the current year, or the current year data for the next year data. So this can be used for only 1 year forecasting, not for the forecasting for the multiple years in the future. So the just previous data is used for the forecasting in the next data. So this is the NAV method. In this case, moving average period is considered only one. But in the case of the simple moving average method, we consider the some period of the moving average. That means we consider that last 3 years or 4 years or 5 years average value will be forecast for the next year. So in this way, we do the averaging of the certain period, and this value of the period or number of the period is decided by the forecasting people. And here normally we use the 3 period moving average or 5 period moving average. If we consider the 3 period moving average, for example, we want to do the forecast for the year 2021, then we will have to take the average value of the actual demand of 2020, 2019, and 2018. So considering these three demands and the average value, the demand of these 3 years will be forecast value for the 2021. Similarly, if we consider the 5 period moving average, then we will have to consider the demand of the year 2017 and 16 also, and then we will consider the 5 period moving average demand for the forecasting of the 2021. So this is the simple and basic method to use the simple moving average method, and this formula is shown here. This is the forecasting for t plus 1 year, and this is the average value for dt1 dt minus 1, then dt minus n plus 1. So this is the n period, and for n period we find the average value which is forecast for the t plus 1 period. Then this is the formula for the simple moving average method. Now we will learn that how to use this method solving the numerical problems based on the forecasting. Here this is the method using the simple moving average method. The actual demand is shown for the 11 period or for the 11 month, and we want to do the forecast for the 12th month. So in this case, we can take the value of these 3 periods. If we use the 3 period moving average, then these 3 period moving average value, this plus this divided by 3 will be forecast value for 12th month. And if we use the 5 period moving average, then we will have to consider from the 7th period. That means 800 plus 708 plus 842 and so on. on divided by 5 in place of 3, and then this will give the forecast for the 12th period. But this value is also very important to know the accuracy of the forecasting. We do the forecast for the past period and we see that what is the forecasting error, so that if you do the forecasting for the future, we can show that what is the forecasting error with this forecast value, or what is the standard deviation in this forecasting value for the 12th period. Now see in this example, this is the 3 period moving average, and this value is calculated by averaging these 3 periods. And similarly, this value is calculated using the averaging of these 3 periods, and so on. Finally, we get the value of the 12th period forecasting by averaging this value. So we calculate the forecasting value in the past also, so that we can compare this forecast value with the actual demand, and we can find the forecast error in terms of the mean absolute deviation, in terms of the mean square error or the percentage error, or in terms of the standard deviation also. So that we can say that if the demand for the period to 12th month, it is 817 plus minus this amount, and plus minus this shows the standard deviation. Similarly, if we consider the 5 period moving average method, then we should consider the 5 period for averaging this, and we can give the forecast for the next period. And in this way we can do the forecasting for all the different periods, and finally the next period, that is 792. Now see that what is the difference between the value of the period averaging here. So in this numerical example, this is the actual demand, this curve shows the actual demand, and this shows the 3 period moving average. This is 3 period moving average, and this is 5 period moving average. Now we want to observe that what is difference between the 3 period moving average and 5 period moving average. If we consider the 3 period moving average, then we can observe here that this is more closely following the actual demand if you use the 3 period moving average. But if you use the 5 period moving average, this is more smoother in comparison to the 3 period moving average. So in this case, using the 5 period moving average, forecasting error is more and it is following less the actual demand. But if you use the 3 period moving average, then this is more accurate in comparison to 5 period moving average method. So this is the difference between the 3 period and 5 period. If the period averaging period increases, then it will give more smoother forecast, but the error may be more in comparison to the smaller number of the moving average period. Now the next method is weighted moving average method. In the case of the weighted moving average method, we provide more weightage to the recent data. But in the case of the simple moving average method, we provided the equal weightage to all the different data, all the past data. But here the recent data is given more weightage. For example, if you use the 3 period moving average method, then in this situation the recent data may be given the 50% weightage, and then next data this may be the 30% weightage, and next to next this may be the 20% weightage. So in this way we can see that the recent data is more important for us, and to observe this trend change in the demand pattern, we give more weightage to the recent data, so that it will follow the actual demand and the forecasting accuracy will be more. Now see this numerical example here. In this case you can see here that we have calculated the forecast value using the weighted moving average. Here this is the actual demand, this is the recent demand, and for recent demand we observed here the weight, that is W1, W2, W3, and this is the recent period demand, and this is the recent weightage, and this W1 must be greater than W2, W3, and so on. In this way, the recent period weightage is more than the next period, so this is the method to give the weightage or to assign the weightage to the different periods. So in the same problem, if you use the weighted moving average method, then we can see here that we provide the more weightage to this data, in comparison to this data, and we provide more weightage to this data in comparison to this data. That means if we provide the 50% weightage to 670, that is the third period data, and 30% to the second period data, and only 6% to the first month data, and we want to do the forecast for the fourth period. So for fourth period, the recent period is 3, so this is given more weightage, and in this way if you calculate the weighted average, that is 670 multiplied by zero point 0.5 and plus 628 multiplied by zero point 0.3 plus 600 multiplied by zero point 0.2. So in this case we can find this value will be equal to 644. It is not necessary that weightage which I have assigned is the standard weightage, and this may be decided by observing the situation and the other constraints also. Similarly, in the 5 period weighted moving average, we provide the different weightage to the different period. Especially for the recent period, we give the more weightage in comparison to the previous period. So on the basis of that, we can calculate the weighted moving average. Now, in this numerical problem, we will observe that what is the difference between the simple moving average and the weighted moving average. Here you can see that this is the actual demand, and this one gives the 3 period weighted average moving method, and weighted moving average method is following more closely to the actual demand in comparison to the simple 3 period moving average method. This is simple period moving average method, this is the weighted moving average method. So if there is any variation in the actual demand, then we are observing here that the weighted moving average method gives more accurate picture in comparison to the simple moving average method. So this is the advantage of the providing the more weightage to the recent data. Now the exponential smoothing method, in the case of the exponential smoothing method, the logic is same as the weighted moving average method and exponential smoothing method. But here we provide the more weightage to the recent data, and the variation in the weightage is exponentially decreases towards the past, exponentially decreases towards the past, or exponentially increases towards the trend, so towards the recent data. So in this case the exponential variation in the weightage is provided. So here you can see that exponential smoothing is the most popular and cost effective of the statistical method. It bases on the principle that the latest data should be weighted more heavily and smoothers out cyclic variation to the forecast trend. It assumes that the data gets older, becomes less relevant, and should be given less weightage. So you can see here the variation in the weight given to the recent data. So alpha, if alpha is given the weightage to the recent data, this is the present value, recent data, alpha is given, then the previous period, just previous period, you can see that alpha into 1 minus alpha, then this is alpha into 1 minus alpha square, this is alpha into 1 minus alpha cube, and so on. So exponentially the weightage of the data decreases towards the past. That means if you go into the past, then the data is not much relevant here, and more relevant data is with the recent data. Therefore we provide more weightage to the recent data. And in this case, how to find the forecasting? Suppose this is the t period and we want to find the forecast for the ft plus 1 period, then we can consider here the actual data, actual demand for the tth period, and actual and the forecast of this tth period, and we provide the alpha value, alpha into the actual demand in the tth period, and 1 minus alpha into the forecast value in that tth period. That means alpha weightage is given to the actual demand, and 1 minus alpha weightage is given to the forecast value in that period. So in this way we can find the ft plus 1, and after finding the value of ft plus 1, we will find the forecast for the each period. As here in this numerical problem you can see that if we use the alpha equal to 0.3, then what will be the forecast value, that is using the equation of ft plus 1. Similarly, if we consider alpha equal to 0.5, then what is the value of the ft plus 1? This is the forecast value, and these are also forecast value. Now we want to compare if alpha value is zero point 0.3, then what is the nature of the forecasting, and if alpha equal to zero point 0.5, then what is the nature of the forecasting. That means we want to compare graphically. So in this graph we can observe that what is the difference. If we use the zero point 0.3 as a alpha, then you can see that this curve shows the zero point 0.3 using the alpha equal to zero point 0.3, but this curve shows the alpha equal to zero point 0.5. So if we use alpha equal to zero point 0.5, this follows more closely to the actual data. This is the actual data. So this is the difference between the weightage assigned to the alpha value, and we can see that if the value of alpha increases, then it could follow closely to the actual demand, but the forecasting becomes very tough, and it is less smoothened. But if you use the alpha less value, then it is more smoothened value, but there may be the more forecasting error. Now see what is the effect on the forecasting by variation of the value of alpha. Now there are some features of the exponential smoothing method. The emphasis given to the most recent demand level can be adjusted by changing the smoothing parameters. That means by variation in the value of alpha, we can adjust the demand forecasting. Then exponential smoothing is simple and requires minimal data. There is no requirement of large number of the past data, because the past data becomes useless for us, or becomes less important for us. Therefore we give more importance to the recent data. Therefore the large number of data is not required in the case of the exponential smoothing method. Larger alpha values emphasizes recent levels of demand and results in the forecast more responsive. That means if the alpha value is large, as we have observed that if you use the alpha equal to zero point 0.5, it is more closer to the actual demand and it becomes more responsive. And if the alpha value is less, that is a zero point 0.3, as we have seen in the previous chart, that is that treats past demand more uniformly and results will be more stable forecast. And then when the underlying average is changing, a result will lag actual changes. So these are the importance of alpha. Normally the value of alpha varies from zero point 0.3 to zero point 0.5. Normally this is the normal range, and normally we take alpha equal to 0 0.2 or 0 0.3. Okay, so this is the average range, but the value of the alpha may be determined empirically also. Now adjusted exponential smoothing. Suppose if there is a trend, or a trend exists in the forecasting, then to adjust that trend we use the double smoothing method, double exponential smoothing method, or this is also known as adjusted exponential smoothing method, to adjust that trend. So for adjustment of the trend, another constant is used, which is known as beta, which is known as beta. So you can see here there is a need to add a second smoothing constant account for the trend. It is similar to the single exponential smoothing. The basic idea is to introduce a trend estimator that changes over time. So trend estimator, so beta leads to trend estimators, and we find the adjustment factor. So considering that beta, we calculate the value of this adjustment factor and we add to the forecast value using the single smoothing forecast, and then in this way we can find the value of adjusted forecast for the t plus 1th period. That means if you want to find the adjusted forecast for t plus 1th period, then we will have to do the single smoothing forecasting as the exponential smoothing forecasting at t plus 1 for that period. But we will have to adjust, that means we will have to adjust the trend for that period, t plus 1 period. Then this is known as adjusted forecasting for t plus 1 period. Now the main thing is how to calculate this value. This value depends on the beta. You can see here t plus 1 for this period. We consider the forecast value of t plus 1th period and t forecast value of just previous period, tth period, and the difference is multiplied by the beta, and 1 minus beta is multiplied with the tth period trend. So initially there may be the very beginning there will be no value of t value, capital T value, then in that case, for that period we consider 0, and later on we find the new value of tt, and on the basis of that we find the adjusted forecast. Now see this numerical example here. There is no trend value. No trend value is given. So here we consider the same value for the next period. We consider the same value, and there is no forecast value is also given. So this actual demand is considered as a forecast for the next period, and then the adjusted forecast will be same because there is no trend value. Then by considering these three value, we can calculate the next trend value, and this trend value will be added in the forecast value, and then we can find the adjusted forecast. Similarly, we will have to find the capital T value for the fourth period, and then the forecast value for the fourth period, and add this value to this value to find the adjusted forecast. So in this way we can find the adjusted forecast for the 12th period is 787.7. Now see the difference between the adjusted forecast and simply exponential smoothing forecasting. This is the actual forecast, and this is the alpha equal to 0.5, and this is the adjusted forecast. This is the single smoothing forecast or single exponential forecast, but this is the double exponential smoothing forecasting. So this is more fluctuating or more closely to the actual data. So if you use the trend adjustment, then it gives more accurate picture of the forecasting in comparison to using the single smoothing method or single exponential smoothing method. So this is the reason that we try to adjust if any trend exists in the forecasting. And this is all about the time series model, and in the next session we will discuss about the causal method and the linear regression method of the forecasting with the seasonal variation in the forecasting. Thank you. Now see you in the next session.